Okay, it looks like we've got the recording going. Just welcome everyone to the SIG Node Resource Management Forum. Today is May 21st. Let me go ahead and share the document. All right, can everyone see the document for today?
Yeah, we can
Yes.
see.
Okay, great. First up on the agenda is the get preferred allocations. Who is presenting this?
Kevin.
Kevin. Hey, Kevin. Sorry, it was a late night last night and I'm a little fuzzy still. So, okay,
No.
I will, you want to bring up the presentation and talk from it from there?
Sure. It says that I'm not allowed to, oh, you're bringing up the presentation, I see. Okay. Sure, so just a quick background on this. So I didn't put it in a slide because I just threw these together right before the meeting started, but kind of the motivation here is to allow us within the device manager to have some influence of what allocations to make given to us by the various plugins that hook into the device manager. Because right now, you know, we've got the topology manager, which lets us align based on kind of per node level information. So, you know, things like the NUMA node, and in the future, maybe PCIe bus ID. But basically, it's that topology hint for the topology manager will really only ever be constrained to properties of the node itself, kind of node-wide specific features and not device-specific features. And so what this API that I'm proposing allows us to do is have the device manager kind of call out to the plugins to allow them to give kind of device, not necessarily device-specific hints back to the device manager so that he can make his device allocations, but actually give the device manager a set of possible device allocations that he could make so that he can incorporate those with the hints that come back from the topology manager and then actually make a much more informed decision about which devices to allocate than what he does today. So that's just kind of a quick background before I get into the specifics. But the first slide I wanted to show here was just a quick overview of how the topology manager currently interacts with different hint providers. So, you know, basically it runs through this quick 5-step algorithm where for every container in the system, the topology manager will call out to a hint provider to say, hey, give me some hints about where you have the ability to allocate this container in an aligned manner. Right now, all we do is ask about the NUMA alignment, but the hint provider has an opportunity to say, okay, if you're asking for 2 of this specific device, what NUMA alignment could I give you? And all of those hint providers pass that information back to the topology manager where you can take the different hints that have been generated from each of the providers, merge them into a single hint, and then call out to allocate in those hint providers so that they can allocate the resources that have been requested in an aligned way based on the hint that was provided and merged together. And if all goes well, then we decide that we'll emit the pod. Otherwise, we say that we won't, right? Are there any questions on this before we move on to the next slide? Okay, Victor, can you go to the next? So with all that in mind, this slide is just a quick overview of what the device manager looks like today and how it interacts with a plugin to actually carry out allocations. Once that allocate call from the level above comes into the device manager, he actually doesn't consult the plugin at all before he makes his allocation decision. The device plugin will have kind of a priori already handed off the list of devices that the device manager could allocate from. And the device manager is just going to incorporate the set of hints that came from the topology manager with that available device list and kind of allocate the devices at random. Right now, it's just, it maintains a list and it pulls the first 2, 3, however many you've asked for off the top of that list, make sure that they are aligned with whatever the merged hint comes in, and then allocates those out. There's no opportunity for the device plugin to come in and say, oh, you know what? Given the current state of allocation and given that merged hint that was just given to you, maybe I'll have some more information about, what might be better, the best set of devices to hand out rather than just picking them at random from the list that I gave you previously, right? That's kind of the high level idea of what we're trying to give some control back to the device plugin for. Next slide. And the proposed way to do this is to add one more API call into the device plugin, which I've called get preferred allocations, which basically adds a level of indirection, kind of one more step in this process of allocating, where the allocate call comes in from the topology manager. And then instead of immediately calling allocate from, the second step will be to call out to the device plugin saying, hey, you know what? Before I go ahead and make my allocation decision, I've already gathered hints from the topology manager. Can I also gather some set of preferred devices that, given that I'm asking you to allocate 2 devices, which 2 are the preferred sets of devices that you would want me to allocate? And then I can gather that information, combine it with the merged hint that I got, along with whatever the available device list that I have is, and make a more informed decision about which set of devices I actually want to allocate out. And kind of the reason that the types of things that the device plugin might do is say, oh, okay, you know what? I want to constrain myself in some topology aware way that I don't want to be integrated back into the kubelet, because it has nothing to do with kind of inter-device constraints. It's all about this device type that I'm currently operating with. And so I'm the only one that needs to know this information about that. So I can incorporate that in independent of the device manager ever needing to know about it. And I can report that information back in the shape of a list of allocations rather than something about my actual topology of devices that I know internally. Any questions there before the next slide, at least about kind of the high level?
Yeah, I was just sort of curious. Is there a particular device or set of devices you think would benefit from doing this?
Yeah, so I work for NVIDIA. GPUs are the obvious answer for us. We have an implementation somewhat similar to this in our internal cluster right now. That's kind of based off of a fork of Kubernetes that we run. Yeah, that's kind of the first use case, but it's the API is designed to be more general for any device type. It doesn't have to be GPUs, because it's just about give me the list of preferred allocations of whatever device type you happen to have, right?
Yeah, okay, great. That's sort of what I was thinking. Yeah, appreciate that, thanks.
Sure.
So I have one question. Why is it called a topology manager? Just want to get some back. Why is it called a topology manager? Is it like yeah.
Why is what called the topology manager? Sorry.
Yeah.
I think his question is, why is this component called the topology manager?
The one that sits above this, the one in the first slide.
Yeah, correct. Yeah, because topology, I am from the hardware, some like background is like it maybe is CPU topology, maybe it's network topology, right? Yeah, or like all the device connected. Yeah.
Yep, that's right. This manages the alignment across all of those devices.
I see.
Yeah, the thing that we're talking about today, though, isn't the topology manager. It's kind of after the topology manager has done some stuff. Now the hint provider, in this case specifically the device manager, is trying to do his allocations based on alignments that the topology manager has told me about. And I don't want to do it based just on what these kind of inter-device constraints were. I want to make sure that I give the plugin the chance to tell me what kind of device-specific constraints it might have so that I can make a more informed decision. Does that make sense?
Can I ask additional question? Like, why you cannot include all this preferred allocation inside of get topology hints? Like, what will be behavior when you you get the affinity from the topology manager once you want to allocate, you get the preferred allocation from the device plugin, so you will be merged and you will merge it with end again, or I don't know. If you fail to get in the end some hint, like you don't have any hints once you merge hint with from the topology merger, and you merge it with the hint that you get from the preferred allocations, and you got the empty set. Like you will not allocate anything, or you will.
No, then it's the idea, at least of this first iteration of this, is that it would be best effort. So you're getting a preferred allocation, but the final decision is ultimately left up to the device manager what devices he wants to allocate.
Okay.
Yeah. Obviously, you could have more sophisticated constraints put in place, where, you know, the same way that the topology manager itself will attempt to, you know, fail admission of the pod if some of the constraints can't be met. Down the line, we could imagine adding something like that to device-specific constraints as well. But for now, this is just kind of designed to work with what we have today in a very minimal way to allow the device manager to make a slightly better decision than what it currently can, without having to overhaul and redesign how everything's organized.
So one follow-up question. So for some devices, when the call from device manager to the plugin is the get preferred allocations, is it likely that some may provide the same hint, or this is probably a different API, so it's a little bit different, I guess?
Yeah, again, so it's not about providing hints. It's probably more clear when we get to an example in a few slides.
Sure.
But it's not about providing a hint. It's about providing, if the get preferred allocations is going to say, it's going to have a little bit more information than this, but it's going to say something like, hey, device plugin, I'm about to allocate 2 devices. Tell me which set of 2 devices you prefer me to allocate.
All right, thanks.
Yeah. So this is the actual proposed change, at least from the API standpoint. There would be a new API call called get preferred allocations, which takes a preferred allocation request and returns a preferred allocation response. The preferred allocation request has 3 fields. One of them is the set of available device IDs. This is the device IDs that I want the plugin to consider when it's trying to figure out, okay, what set of devices should I prefer to allocate, based on the 3rd field, which is the size, which would say how many of this device do I actually want to allocate. And then there's this field in the middle that refers to the must include device IDs. This is given the available device IDs, whatever preferred allocations you come up with have to include this subset of devices. And the reason for passing this along is because we want this API to remain stateless. We don't want to assume that the device plugin knows anything about what devices have already been allocated, what devices may have been allocated to init containers in the past that we want to make sure we reuse in future allocations, and so on. And so this is just a way of, you know, giving them all the information they need to say, okay, I have to include these guys, and this is the list from which I can allocate this specific number of devices. And then based on that, it's going to send back a preferred allocation response, which is just a list of preferred allocations, which currently just contains a list of devices. But if you go to the next slide, I wanted to make sure to leave this last message with an extra level of indirection so that it can include more fields later on as needed. So maybe we don't want to just say this is the list of devices, but we also want to add a priority or a cost of allocating this set of devices versus another one. Does that make sense? We can come back to that second question that's above a little bit later. Okay, next slide. So this might make it a little bit more clear exactly what this proposal is saying. This is a more concrete example. So imagine you've got this setup on the left, which is an actual topology of a DGX1 Volta machine, which has 2 sockets, 40 CPUs on each socket and 4 GPUs on each socket, where, you know, those constraints, if I've got this socket, I'm on this NUMA node connected to these CPUs and whatnot, those are kind of per node constraints that I would want to eventually incorporate into my topology manager node level topology hints. But a constraint that should probably never be encoded there that this API allows us to now encode is the interconnection of different GPU devices using this interconnect technology called NVLink. So if you can see the green and gray bars down below, you can see how, for example, GPUs 0 and 3 are interconnected by two lines, a gray one and a green one. That represents that these guys have a strong double NVLink connection between them. Likewise, 0 and 4 also have this double connection, but 3 and 7 only have a single link. So that's, a slightly stronger link, a slightly weaker link than if you have two of them between them, right? And, it just kind of builds up a more interconnected topology of these GPUs, which implies that, if I'm ever asking for two GPUs, I'm going to prefer some set of two over a different set of two, right? And so that's exactly what this API would allow me to encode when I send this back. If the request that I got coming in was, hey, no GPUs have ever been allocated yet on this system. There's 7 of them available. Someone's asking for 2. What is the set of 2 devices that you would prefer me to allocate? And based on it running some internal algorithm to figure out what the best set of 2 devices it would prefer you to allocate would be, it's going to send back this response saying, if you're going to allocate 2, I'd rather have you allocate either 0, 3, 1, 2, 4, 7, or 5, 6. I don't want you allocating 4, 0, for example, because that would be a non-optimal interconnect of my NVLinks and other topology constraints that it takes into account. Next slide. Likewise, if the request for 4 came in rather than 2, you'd want it to be able to, return a similar set of preferred allocations, where this time it's, obviously the 4 on the left versus the 4 on the right. This is actually the same allocation that the device manager by itself would come up with if it was just doing allocations based on NUMA constraints. But obviously the previous one wouldn't have been necessarily the one that the device manager would come up with even today. And then the last example I have on the next slide is just incorporating this notion of having the must include device IDs where, if I pass the available ones as all 8, and I want to make sure that it always includes all 4, 0 and 4, then it could run its algorithm under the hood and figure out, okay, well, if that's the case, then the preferred allocation I want you to do is 0, 4, 1, 5. Again, based on this kind of internal topology constraints that it knows about for these specific device type. And that's basically all there is to it. There's not, again, there's not a whole lot to this proposal other than adding this one quick call out to help the device manager be a little bit more informed about its allocation decisions instead of just picking from random from the device list that it's given a priori. Can you go to the next slide? A couple of things to point out is that we would make getting preferred allocations a completely optional call. So if a device plugin doesn't want to implement this yet, it doesn't actually care about making any preferred allocations. It's, it's equally fine to get 2 devices from anywhere amongst the ones that it's made available. It doesn't have to allocate this at all. The device plugin will, just notice that it's not implemented and not do anything with that information. Or sorry, the device manager will do that. It's also worth pointing out that we've, if you look at the KEP, I've kind of walked through what would happen in all of the 4 possible cases of, interacting with between the device manager and the existence of this API call or not in any of the plugins. And so I encourage you to kind of take a look at that KEP and comment on it to make sure that what I've said for each of these cases makes sense. But in general, it will gracefully handle all of those in a way where nothing will change from how it is today if no one ever implements the get preferred allocations. And nothing will change from how it is today if someone disables the topology manager and also doesn't implement any of these new API calls. And the last thing to point out, as I mentioned at the very beginning, was any of these return preferences that come back will always be honored in kind of a best effort fashion. It's not meant to be as kind of configurable and tunable as the node level topology hints that we are able to set up with the topology manager. It's really just a way of doing a little bit better than what we have today with a simple API call, extra API call out to the plugin. And then the very last slide is a couple of quick questions. The first one being, you can imagine if, imagine I've got 100 devices rather than just 8. And they say, hey, I want you to allocate, give me the list of preferred allocations for 2 devices. It's possible that you could end up with some explosion of possible combinations that you would want to send back because, you don't really care about, too much about which sets that are allocated, but you want to make sure that it is constrained somewhat. So you end up sending back a list of 4,000, 5,000 separate combinations. That doesn't seem like something that, would be tractable in the long term. And so does it make sense to pass along the topology hint so that you can actually have the plugin incorporate that and limit his response based on it? Or maybe instead of doing that, we don't have get preferred allocations return a list of preferred allocations. Instead, you actually you kind of pre-filter the list of available devices that get sent in to have already taken the topology hint information from the topology manager, namely the NUMA constraints into consideration, limit the list of devices that are passed in kind of pre-filtered by that, and then only have the plugin return a single preferred allocation based on the devices that have come into it. And again, maybe there's only 2 left on the machine after this pre-filtering happens. And so now the device plugin doesn't even need to call out to the device manager doesn't even need to call out to the plugin because it's got all the information it needs to do that allocation. And that's kind of the combining both of these questions. Should we add the topology hint as an extra parameter so that the plugin can take that information into consideration? Or does it make sense to just have a single allocation be returned back? It simplifies what the plugin would need to return. The semantics with the user are much clearer. It doesn't, because it knows it can only pass one thing back, it doesn't have to worry about, coming up with an entire list of all the possible things that it would want you to allocate. It just needs to come up with something that's good enough that hopefully the device manager will just immediately be able to honor because he's already pre-filtered it by whatever other topology constraints were put in place. And that's it, unless other people have other questions or comments on any of it.
Yeah, Kevin, there's a few questions in the chat.
Yeah, I saw them coming in.
Okay, you want to talk to those for a minute?
Yeah, let me see if I can pull it
So
up.
BG is saying, hey, he's curious, is it possible to allocate GPUs from NUMA node 1 when the best hint is 0001 true?
From NUMA, so in your example, BG, is that 1 on the end, meaning NUMA node 0 has the 1-bit set, but NUMA node 1 is actually set with a 0 right now? Oh, got it. Or you corrected yourself. Actually, I don't see the difference in your question. I think that the short answer probably is no, because again, the final decision is ultimately left up to the device manager, no matter which way this works out. And so even if you prefer, if the plugin sent back a preferred allocation that included something that was impossible to combine with the NUMA constraints that came from the topology manager, the device manager wouldn't do that allocation. It would instead ignore what the plugin said and only allocate according to the topology manager constraint. Does that answer your question, BG?
So Kevin, I had
Okay. Yep. Go ahead.
a question, if it's okay. Let's say we do this. How would you want the project to test and sustain it?
Can you say that last part again? You broke up a little bit.
How would you see our existing testing around device plugins
The testing right.
evolving to account for this? Like, would we be writing a mock device plugin stub that exercises this additional call? Like, one of the things I'm trying to think about when we look at all these things is just like, what's the sustainable way we in SIG Node ensure that we don't regress as we get more?
Yeah. Yeah, I think that it'd probably be a combination of, obviously extensive unit tests where we kind of mock out what we expect the device plugin to do based on things that come from, a device plugin that's just, mocked out in the unit tests. But I think also we would want to build an extensive suite of, integration tests, the ETE tests that we have. But again, I think you could do it with a mock plugin, a stub plugin, like you mentioned. It doesn't necessarily have to be a full-on device because, it's very easy to write one of these stub plugins because the plugin interface is very, very simple. All that the plugins do is enumerate a set of devices back to the device manager. Device manager notes those down. And then anytime it decides to make an allocation, it kind of informs the device plugin, who then has the opportunity to tell it, oh, here's some things I want you to pass down to the container runtime based on the fact that you have decided to make that allocation decision, right? So stubbing one of these things out to, not necessarily test that a device plugin itself works, but that the interface between the kubelet and the device plugin works is actually pretty straightforward. Does that answer your question?
Yeah, it does.
Great. Okay, so the second question in the Zoom chat was, is this call per device only? Do we support the combination of devices? So again, this API call is all about doing device-specific constraints and kind of encoding those in this preferred list of allocations that come back. And so yes, it would be device only. Any inter-device constraints are in the domain of the topology manager and whatever extensions we make to the topology hint down the road. Right now, that's just NUMA node, but you could imagine adding PCI bus ID or any other number of kind of inter-device constraints later on. Right.
Do you hear me?
Yep, go ahead.
Sorry for audio quality, I'm a bit on the road. So, Kevin, one thing which I wanted to note is what I listed in the Slack our CAP proposal to enhance the algorithm for selecting like inter-devices.
Mm-hmm.
And what I'm thinking, it will be a lot more useful to actually extend the topology hints to actually include this cost metrics inside the device and between the devices. Because when it means like the decision about the thing like selecting multi-device or within multiple instances within one device, it will be on topology manager side. Because if we add one more call, this additional call might be used as a to trick topology manager. So like imagine the situation where topology manager says like, I have these 6 devices available. And clever device plugin says like, oh, so somebody is going to allocate this subset of devices and this 6 is available. So let me trigger what like the only preferable is that combination or that combination. So this additional call might be just using to override the, well, influence the topology manager decision in the bad way. And if we do like the cost and or cost-based definition between the instances of the devices, between all the device plugins, and maybe system resources as well, when it will be like one clear algorithm why it was selected.
So that you can kind of a priori, as the person that's about to deploy a pod to this node, kind of know if this set of constraints is true, I know I'm going to get this kind of alignment. Whereas this is going to be a bit more up to the different plugins in some ways as to what devices you'll actually get allocated at the end of the day. Is that the worry?
Well, my worry is what, so if the plugins will report the graph of interconnect between the devices and between the instances of the devices within one domain, when it will be one single clear algorithm. If if we do additional call, it means what's like some preferences will be dynamically changing if this plugin will implement some clever logic in this additional call.
Yeah, I see what you're saying. So it's the idea that we're going to be calling out to the plugins one by one. They're going to be making some decision rather than kind of looking holistically across what would be the actual best allocation given all of the topology constraints in the system. Is that?
Yes.
Yeah.
So I'm really afraid what this plugin will be on the fly changing their own preferences.
So I don't understand that piece of it, the on the fly changing the preferences, because again, it's really just about it's doing a little bit better than what we have today, where right now, all that's happened is the device manager says, I've got this list, I'm going to pick 2 random things out of it. I don't see how it could be any worse adding this one quick API call to say, you know what, go ahead and give me some hint on what you would actually prefer so that I don't just pick 2 things at random. I instead have a little bit more informed decision about which 2 for whatever I'm going to pick.
No, what I'm saying is like this call is an improvement for the current situation, but it's worse when the plugin will say, here's my like 8 instances of GPUs, and this is how we're interconnected, like emphasizing some cost between them.
Yeah, so you're saying that in some future world where we have the ability to consider all the costs and, you know, based on how the topology is set up across all of the different devices, having this extra API call would actually in some ways maybe hurt the situation because I've already made the optimal decision, and now calling out to that might trigger something to change from what I've already decided on.
Yes.
Yeah, I see what you're saying. I need to think about it a bit more. That actually, what you just said leads me to think that if we do add this API call, it should be more of the form that I had in the very last slide, which is the topology manager, whether that's your cost-based algorithm or what exists there today, will pass whatever hint information it needs to down the device manager so that he can make his allocation decision. And now that he has that in front of him, he can use that as a pre-filtering to decide if it even makes sense to call out to this API call to the plugin, because he still has a little bit of leeway in the options he could make. And then now that he says, okay, there's 3 devices sitting here in front of me that I could allocate 2 from, why don't I go ahead and ask the plugin which 2 of those 3 I should go ahead and do? You know, so it doesn't interfere with the higher level algorithm, but given the option that there might be some leeway there, it could call out to this to allow the plugin to make that kind of last level decision. Does something like that make sense?
Well, sorry, I don't see the screen, so I need to look at it afterwards. For this particular scenario.
Let's take this offline because I read your guys' proposal a few months back, and I need to take a look at it again because I definitely don't want to introduce something that will, you know, preclude us from making better improvements internally to the way that the topology manager operates today. Right?
Yeah, and another thing which I wanted to say is what this call will be like within one domain of devices. And I know like NVIDIA just recently introduced 100 devices where you have not only GPUs, but you also have like connectivity like close to GPUs. Mm-hmm. So you very soon will end up with a scenario what you need to have a pipeline of devices. So I would suggest let's think about actually to expose like the real topology between the multiple domains of the devices, rather than trying to constrain.
What do you mean by domain of device in this context?
Well, for example, like GPU plus some like NIC or GPU plus FPGA or something like generic PCI device. So like when we like example NVIDIA 800, you have GPU with connected NVMe directly. So like you might want at some point allocate this GPU plus this NVMe for your workload. It was some one shot.
Yep, I completely agree. Sorry, what's the question in there?
What I'm saying is let's think how to expose like multi-device preferred selection rather than trying to fit right now a single type of device.
Yeah, I still think we should take this offline because I still think that having this, again, like I said, if it's kind of just the last level of hint, if you want to call it that, would still be beneficial, even if we have solved the constraints that you're talking about in a more cost-based analysis way. So again, I think we can take this offline because you've obviously thought quite a lot about this proposal, and I don't want to take up everyone's time with, talking back and forth. Have a better handle on how they would interact, right?
Okay.
All right. Yeah, let's take offline.
Yep.
That sounds good. So I put a note in the doc here just to sort of take a look at Alexander's presentation and sort of compare. So okay, any other discussion on this presentation?
One quick question before we move on. Within the preferred allocations request, how do we set the must include device IDs, or where is that set? Maybe I missed that. I'm sorry.
What do you mean by where is it set? So the device plugin, the device manager would set that based on knowing that these set of devices need to be included in whatever preferred allocations you send back. And one of the main motivations for that is init containers, because once you've allocated something to an init container, those devices should be reused in future app containers if possible. And so, if I've given two CPU or let's say GPUs in this case, I give two GPUs to my first init container, and the next thing is an app container, he's asking for 4 GPUs. I don't want to just say, give me any 4 from this list of devices I send you. I want to say, here's the available GPUs that are there. Give me 4 of them, but you have to include these 2 because I know that I've already handed those out to an init container that's going to run before you. Does that make sense?
Yeah, that makes sense. Thanks.
I also had one question for this, like a device ID. Are they discovered by the device manager or the aware as like in the topology manager level? Because also, yeah, this also like the related to your asking the slides question, because if you pass on the topology hints to the device plugin, right? At that time, whether is a high level like hints, or is like the device ID level?
This is kind of out of scope of this. The way that all that information is everything originates from the plugin, both what the NUMA constraint is and what these device IDs look like. Those get handed off to the device manager, who then uses that information to pass it to the topology manager, who then merges the hint, which then gets consumed by the device manager just before it's going to make its allocation decision. So what the set of devices are, what their topology constraints are, always originates in the plugin itself. Does that answer your question?
Yes, thanks. Yeah.
Okay, so we've got about 15 more minutes left. I think we've got this pretty much covered. And how about we sort of take the rest of it offline so we have enough time to go over the other stuff? That sound reasonable to everyone?
Yep. Thanks, guys.
All right. Thanks, Kevin. All right. The next item on the agenda was offline review requests for Derek. Talking about support pod level resource alignment. There's the enhancement. Any discussion on that, or are we going to the next one?
Chris here. If you could let me share the screen, I think in 3 minutes, I can show the difference from the last update about that.
Okay.
I guess I'm curious how others feel about that enhancement.
Actually, Kevin left us his, I think it is informal approve, and the concept changed a little bit from the last week, so that I wanted to present that.
Yeah, I mean, let's do that. I just wanted to make sure that
You're talking about the pod level topology policies. Is that, yeah.
Yep. And yeah, like Kevin proposed, we changed that to the idea with the topology manager scope, where you select the scope in which the topology manager will collect hints. The scope is either a container by container or pod by pod. And yeah, we applied the comments that you left to us, and
Yeah,
yeah,
Derek,
we wanted.
I don't know sorry, I didn't mean to interrupt, but Derek, I don't know when you last looked at this, but previously it was proposed as a new policy called pod level single NUMA node. And I came in and kind of counter proposed that instead of having this one-off pod level constraint for the policies, you'd actually, if we're going to introduce anything like this, it makes more sense to say whether all of the policies apply per container or all of the policies apply per pod. Meaning that if I wanted to make sure that all of the resources allocated to any container in the pod have to be aligned versus just on a container by container basis. And so the feedback that I gave was, if we're going to do this at all, it should be kind of a second level flag, which is this is the scope on which the policies apply versus just adding one by one more and more policies that do slightly different things.
yeah, I appreciate that. That was what kind of the earlier iterations I had seen. I was struggling to think if we added the pod policy as a peer to single NUMA node or restricted, like I really wasn't sure if we were reaching a state where I would know how to recommend a end user how to deploy the system anymore. So I think the scope variant makes sense. One of the things I'm curious about though is in light of the pod scope being identified, do we feel that our present default is wrong?
Meaning going by container rather than pod at the moment.
Yeah, like how do folks feel that container by container use cases are more prevalent or pod by pod use cases are more prevalent? It seemed like PG, if I recall, felt that his use case in particular mandated that it had to be pod, but I was curious if on the same note, if there was another use case that said the container use case was required as well.
Well, based on our trials, we're mostly thinking about the scenarios what like affinity, anti-affinity, because you might have, let's say, two data processing containers, which needs to be strictly aligned. But when you can have like bunch of sidecars, which you really don't care, because the amount of CPU time, amount of data traffic is going to those, or like shared memory, it doesn't really affect much of performance. So it might create more problems in this like more than two containers setup.
So I guess one of the things I'm curious about is, I think this enhancement predates, Alexander, your discussion where you kind of added tacit hints in the pod spec on if you would prefer potentially container versus pod scoped alignment. What I was trying to figure out, and hopefully after we got through all our discussions here on what people were interested about, is like, do people feel that we could combine, say, this enhancement with some of the concepts that you had presented last week or 2 weeks ago in SIG Node to get kind of to a more unified end state, where rather than have the kubelet necessarily be configured one way, we could allow the pod author to express the performance constraint they desired?
Well, as a first step, I think like having the additional policy which aligns everything within one pod, it's a good progress. We only just need to be prepared to scenarios what it might be not available like amount of resources. So we again come back to this to a scenario of rejecting the pod from the node. So we just need to be prepared to that scenario.
Yeah. So I feel like what I'm cautious about is once we add this, in my view, we can never take it away, right? Like, I'm not naive enough to not understand that like global 5G networks will start deploying with this on, and it will be the thing that is expected to work for the next 50 years, right? And so I just wanted to make sure that like as a community, especially you, Alex, and your view was being heard, because I felt like it was possible we could blend the two concepts into one outcome. And maybe I'm mistaken on that, but just wanted to get the broader engineering community's here's feeling on this, because I view this as saying like I'm going to have some use cases where I want container level alignment, other use cases where I want pod level alignment, and it's not clear that you'll have a one answer fits all outcome on a node forever, and maybe that is the outcome for the next 12 to 24 months. But I just felt like this was a forum for us to ask if some of the ideas that you had presented should be collapsed into this, so that the desired UX could be expressed away from the node configuration, but on the pod a little bit.
Desired UX, I think it's well, we already have in pod spec with node affinity, anti-affinity pattern, which we are using for the scheduler. So if we can expand the pod spec to include also this like container affinity and anti-affinity, then we can achieve all those like variants of combinations. Like regardless how on the backend it will be implemented, it will be just like one single UX for the user. The question is like, well, based on how I observe the pod spec changes that come into the Kubernetes, like it's very long road to go. So if for Samsung we need to enable something right now, and we have topology manager right now, maybe it is a temporary solution until we get the pod spec defined.
Yeah, I don't believe anything's temporary. Like once it's in, it's in. And so I think there's an opportunity here that we could explore this. The only other question with like pod level alignment would be things like debug containers, or, we got a lot of pushback from other communities who have desired a sidecar container type, largely around folks that wanted different pod shutdown semantics, or did Envoy style or Istio style sidecar injection. And so it wasn't clear if we look at the use cases of pods that would be authored, are we assuming that if a pod is authored, is the same user using Istio or Envoy or something else that might inject a sidecar, that you would still want pod level alignment on that container or not? That was the other concern I had. And I want to, I'll put my red hat on right now, which is like, if I say that, if my understanding is like when many of the performance sensitive environments that people want to get these workloads into, the user community that wants to take advantage of all the innovation we have out of our ecosystem will often say things like, well, I want to combine Istio and core Kubernetes and all these things at once. And the the intersection of like the final outcome pod spec is not always as simple or understood. So I just understanding, like if we did pod level scope alignment, are you getting the right outcome if that is a user who's using Istio or anything else? Is just something I'm trying to be sure that we're careful about, or at least calling out. Same with everyone in like the CNF space. Like it's hard to like show someone like this is the pod spec for a CNF function, and or if folks will go and write other mutating webhooks that change that CNF at deployment time. Like, so in general, I'm kind of wondering like, is it better if we find a way to blend the hinting model you had, Alex, with a static configuration model that this proposal defined? And I'm also very open to being convinced like that's just a horrible problem to try to work out, and let's make progress as a community and do incremental steps. But I do want to use this as a forum to like actually have an open conversation about that. Like, does that, am I the only one who thinks about that maybe, or maybe Kevin, I don't know if you have a perspective.
Yeah, no, I agree with what you're saying. I hadn't thought too much about the fact that 25 years from now, someone might still be using this, but I do tend to agree that, you know, once something's in, whether it's beta, even alpha, some people will always come back and complain that, hey, this was there. Why did you take this away from me? What's the alternative now? So I agree, we should definitely think carefully about whether we want to add any flags ever.
Well, my way of thinking is what, like, if the new feature will supersede whatever it was previously, then it will be easy to obsolete. But yeah, I agree. We have an opportunity right now to define like how it will be visible for the user for the next several years. So let's come up something usable.
Yeah. So if
Yeah, I think
my ask is that like I don't want to make a final approve or not approve on any particular enhancement until we feel as a group we've gone through the design space. And if we feel like after today's call we've done that, or we have a couple other calls that we want to have, I really want to use this as we have 20 super sharp engineers together who have a chance to try to get as much alignment as possible in one design space. And if it turns out that there are enough unique swim lanes that we need to take 3 different approaches, that's fine. But like right now, I'm not feeling comfortable to approve this enhancement until I feel like the other 18 folks on this call are in complete alignment as well. Does that make sense?
Yep.
Yes.
Okay.
Thanks.
Yep. Okay.
Yep.
So, all right, with that, what do we want to do then? Continue to review both presentations and come back.
Yeah, I think we
prepared
should. Well, we should encourage people to go and comment on the KEP PR, either with their kind of, you know, loose approval or any concerns and questions they might have based on what Derek has brought up.
Now, just to maybe give a little more, I view the changes to the topology manager policy slightly different than maybe I view, Kevin, your preferred allocations proposal. That one seems way more just incremental. Mm-hmm. And so from my perspective, that one seemed pretty good, right? Like I didn't see a negative on that right now. But I do want to think about like the topology manager, memory manager stuff as a single outcome.
Good.
Okay. Okay. Any more comments or discussion on that? Okay. If not, there's one more item. What's our time check? We have 1 minute, and it was really about the memory manager discussion that we had last week. So do we want to take time to a few minutes and go over with that now?
Yes, if you could I will just ask two questions and maybe present this presentation next week.
Okay.
Mm.
Well, okay, we'll wait on the presentation and go ahead with the questions.
Could we open the slides?
Yes.
And just go to the fifth slide. Sorry, to the sixth. The next one, yeah. So recently there was a concern about user experience, and it was caused by the number of flags that we propose. So we just came with the idea that maybe in alpha version of Memory Manager we could simply skip some flags. What do you think? Because otherwise, for example, here in this slide, I discussed multi-NUMA groups flag, and I started to wonder what would be the alternatives that we have if we don't want to include this flag incorporate this flag into Memory Manager. And one of the options is exactly to skip the flag for Alpha Memory Manager release. It's to facilitate the review process and maybe also the approval.
So maybe what we can do on this one is, since we are over time, like I think there was some confusion this week if we were supposed to hold a meeting on Tuesday morning or not. Do we want to have a meeting to allow you to go through this slide before next Thursday, which I'm more than happy to do. And maybe we can leave this call with parting thoughts on having folks review those slides and think about your question. But do we want to meet sooner?
On Tuesday, you mean?
Yeah.
For me, that would be great. It's not an issue. So maybe.
Yeah, I think that sounds great to me. If we met Tuesday.
And then, kind of an ask I have for folks here is a tension I've been struggling with, which is should we optimize our design thoughts around clusters for specific use cases, where the way we approach flags and configuration would be, this is what the recommended kubelet config for an AI cluster would look like, and does that look different than the recommended config for a cluster running CNS, right? And I think it's helpful for us if we, as a community, come to grips with the idea that, do we see node pools configured for particular workload types? And maybe I'm putting thoughts in my head, Kevin, which aren't accurate. Like in my mind, I'm thinking NVIDIA wants to run certain type of workloads on GPUs that might be different than the workloads that packet processors are running, and maybe that's a mistake on my part. But
that's definitely true. And not only that, I'll just add one more thing there, is that we plan on constraining the way that the nodes are organized, what types of machines are there, what labels you put on these nodes in a way that lets you run scheduling algorithms differently and so on. So it's very kind of, it's very customized in that way. It's just general purpose workloads would be in a different cluster.
Yeah, and so that's kind of the design tension I have when we talk about UX, and maybe some of what Alex's proposal did, which was I kind of view Alex's proposal as, I have a general purpose pool of compute. Let me give you hints on the right way of doing it. And then I view some of the work that Kevin, you're pushing, or some of the work that BG and Samson is pushing as saying, I have a particular class of workload I want to run best on a cluster that's been tuned for that workload, whether that is AI inferencing models versus packet processing environments. And I think we are well served at understanding how to evaluate proposals if we say, like, as a Kubernetes deployer targeted on this workload type, I recommend we structure nodes as XYZ, and starting to like define the dividing lines that may or may not exist between those different workloads types. I think that is very helpful as well, because then the UX around flags is less interesting, right? Because vendors like Intel will put out documentation that says, this is how to best configure your Kubernetes cluster to run DBDK or something, right? And NVIDIA could put out documentation that says, this is the best way to configure clusters to run XYZ, right? And Red Hat would be no different. Right now, I think there's a tension on, do we want to solve general purpose or do we want to get more domain specific? And maybe each of the proposals that people have out there right now, we can better understand each other, a community, if we say, like, this is the workload I'm targeting and this is the recommended node configuration for that workload type. And I think that would be helpful for me personally, and maybe helpful for all of us to understand how to evaluate if there is a one size fits all answer or not for some of these things. Is that a
Derek,
fair?
actually, one thing which I haven't shown in my presentation, but we also thought about this kind of user experience or sysadmin kind of experience is what, like, our proxy, when it starts, it expects to get a config. And we have a daemon, like, oh, actually a daemon set, which reads the config map and then pushes the configuration to this CRI proxy daemon. And it can dynamically update, so it can dynamically reconfigure itself. And it also understands like several levels of fallbacks. So there is a one config map for the whole cluster, like default. There is one config map which can be defined by the group. So you can label your node with specific group and it will fetch the config map specific for that group. And then there is a config map specific for one particular node. So the node name is used as a key to look up a config map with configuration, and like all these kind of like divisions and hardware specific particular to that node. So it's possible to group all of those.
What I've struggled on that one, and I understand that, is like it's like an answer that says, I want to allow every possibility. And what I'm trying to figure out is, like, do we focus on purpose-built clusters or general purpose or multi-purpose clusters where each purpose is tied to a node pool or not, as like a first thought. And where I see a tension is, like, for, let's just pick on edge, where I see a lot of folks that say, I want to run clusters on the edge. And initially they have a very particular use case they might run around the edge, and I'll just say packet processing, right? And so there it's like, the hardware needs to be awesome, everything needs to be awesome, my workload needs to run as fast and awesome as it always did, and it needs to do that for the next 12 months. But then, you know, maybe 24 months from now, I want to start running other general purpose workloads on that little cluster at the edge. And I want to know if everyone's goals kind of feel like those goals or not, or are we going to say, like, hey, for the next 12 months, we're going to, as a community, say our recommendation is you build a cluster for a purpose, and when you have a new purpose, maybe you build a second cluster? Or are we going to say you add a second node pool to an existing cluster? That's like a key first tension I'd like to figure out.
Well, when we were designing, we were thinking what, like, you can have a heterogeneous cluster. So you can have like different kind of nodes. They can be organized in the groups, and you can have like one shot specific nodes. So for example, like like talking about the edge, you can have like one node or two nodes, which is like data processing, like radio. And then you can have a couple of more nodes, which is like generic applications. And then you can probably also have a VM in like where like some other cloud like connected to the same cluster, which will be doing something else.
Yeah, and then the reality of that though is always tied back to what are the workloads you want to deploy. And so like if you have one workload that deploys X and it prereqs a certain level of cert manager, and then you have another workload that deploys Y that had a different level of cert manager as a prereq, then like inevitably you had a tension there too. And so I'm just trying to like ask that for each proposal that's presented forward, if we can put it in the context of like its intended use. That's all I think would be good. Like in 2 weeks, if we came out and said, we think this enhancement is awesome for this use case, and we're going to go and try to explore that for that use case, and this enhancement is awesome for this other use case. We always have the clear use case in mind, or the consumer in mind, for why we're pursuing any given enhancement, rather than leaving it up to the deployer to guess why we built something, I guess, and or didn't take a more general purpose approach. So either way, that's my general ask, if we can just be like cognizant of that. And so I appreciate, Kevin, you calling out that like that is what you are desiring, right? And I'm sure the other proposals are here targeting specific cases as well. Either way, so do we want to meet again on Tuesday morning? Is that what we're getting consensus?
It seems like there's a couple plus ones in the chat, and that's fine with me as well. So
Okay, all right, awesome.
Okay, if that's it for today, I'll stop the recording and send out a meeting invite for next Tuesday. And thanks everyone for attending, all the great input. And